Good morning. So today we are going to start with another interesting new module. Where the module title is Properties of Sections and Solids, right? Surface areas and solids. So let me just share my ActInspire board for the class. We hope you are able to see this screen. And in the last class, we were just concluded with this ladder friction problems, right? So you see that there are two problems that we solved on the last class, and I have ended with this second problem where I have asked you to do the second part of the question as a homework, right? So what was that question is, so when you have this ladder which is lean against wall of height h, where that ladder has been extended further than this height, and you have this lean angle with the horizontal theta, right? So you have to show that if the ladder is on the point of slipping, you have to get your angle cos theta minus cos cube theta is given by this expression. So this we were able to do it comfortably by applying conditions of equilibrium on this free body diagram, and you are able to derive this expression, and hence you have proved this, right? So this is first part of the question. So what was the second part of the question that was asked? Then show that if look at in this expression on right hand side, this expression of right hand side is what is there here. So if I have here this 2, then I can put 2 here. Then this is going to be 2 by under root of 27. So show that if this value is greater than 2 by under root of 27, the ladder will not slip at any angle. That's what is asked. So what should be this maximum angle theta, so that for any angle this will not slip? That is the question, right? As this angle theta is reduces, there is a chance of this slipping. As this angle theta is increases, so the lean angle is very small here, so it will be able to be stable there. So you have to prove this second part. How many of you have done this second part of the question? Anybody has solved for this? So who are all present at the moment? There are 23 students. So yeah. Priyansh Pandey, have you solved that problem?
So I tried doing it after class, but I couldn't get it. So I tried once or twice, but I couldn't get it. So I left it for the time being.
Okay, okay. Anybody else has solved in the class? Venkat Satvik, Sanjay Anto, K. Aravind. I see these are the names. Hanna Chindu Rai. This second problem is kind of conditional problem, right? So how do you solve? Let me explain you. Then we'll get into a new module, right? So let's go to that part. See, what is the condition here is, you see that you are given this. So first part of the problem, you have proved that cos theta minus cos cube theta, which is equal to 2 mu s there's some issue with this ActInspire board. ActInspire board is not responding this time. Yeah, it's back. So this cos theta minus cos cube theta equals 2 mu s into h by 1 plus mu s square into L. So that's what we have proved, right? So now next question is, if this value 2 mu s h by 1 plus mu s square into L is greater than 2 by under root of 27, the ladder will not slip at any angle. Will not slip at any angle. So this is what you have to prove. How this value comes? Greater than this value, this ladder will not slide, it is said. So how can you get that? For the ladder not to slip at any angle, we have to show that the maximum value of this angle of this function cos theta minus cos cube theta. For this, we have to show that the maximum value of cos theta minus cos cube theta is equal to 2 by root 27, right? So this is what you have to prove. So how can you do that? So this is function of theta. This function can be having its maximum value. How can you find out? Differentiate this with respect to theta. So d by d theta of cos theta minus cos cube theta, that's going to be minus sin theta minus 3 cos square theta into minus sin theta into d theta, right? So that's there here d theta down. So that's what is should be equal to 0. So when I make this is equal to 0, I would have here, see the sin theta can be, so this is in product. So I can take this sin theta on one side, the remaining on the other side. So here it is going to be sin theta, because this two product is positive, this is negative. So sin theta equals 3 sin theta cos square theta. So I would get here this sin theta goes out. So it is cos square theta value equals 1 by 3. Therefore, cos square theta value is 1 by 3. So you get cos theta value is 1 by root 3. Plus or minus 1 by root 3, I take plus value. So having this now, for this value, I'll have its maximum function. So substitute this in the function. So if you substitute that in the function, what you get? You would get cos theta minus cos cube theta of its maximum value would be substituting this 1 by root 3 minus 1 by root 3 square, that's 3 into root 3 cube, right? Yeah, 3 into root 3. So that's going to be, if I take LCM 3 root 3, so I would have here 3 minus root 3 minus 1. If I take LCM as 3 root 3, that's going to be 3 minus 1. So I get 2 by 3 root 3. So here I can rewrite this as 3 as root 3 into root 3. So it's going to be 2 by the root of 27. So that's what is, that's maximum value. So if any value greater than any value, if 2 mu s h by 1 plus mu s square into L is greater than 2 by root 27, then this will not have. So this is the maximum angle it can hold. It can hold just an equilibrium, right? It is any angle greater than this will not make. So if this is the condition come, then the ladder will not slip at any angle. Not slip at any angle. So you see that this problem is very interesting. That we have this condition is proved, right? First condition problem is what? A. You have to show that if the ladder is on the point of slipping, right? Then this is what is the expression of this angle. So you get your mu as, see this right hand side, you see it is surface characteristic, height geometry, L is the geometry of the system. So it is given in terms of surface characteristic and the geometrical values. So that is going to be function of that is expressed like this. So you have proved that from the condition of equilibrium, considering at point A and point C, the friction force developed are the maximum possible values. So that is why it is said that point of slipping. So the values of frictions that you have to take here is not simple static friction value. It is maximum static friction values at these 2 points. So you have proved. So you have now the second state, if this value is greater than this, so this number comes how is what is that? Simply, if this function cos theta minus cos cube theta is function of theta, one of the independent coordinate of the system, then if you differentiate that and equate to 0, whatever the value you get, you for that value you would have this is the maximum value. So that is exactly what we were doing in the second part to get your cos square theta value, cos theta value. So cos theta value happens to be 1 by root 3. Then when you substitute back, you are able to prove this. Right. So I hope that you have understood this problem. Now we will get into the next module.